Alright friends, welcome back. In this video I'd like to go ahead and cover section 1.7 of your textbook, and we're going to take a first video for this. We'll have a backup video here later on. But in this video specifically I want to go ahead and discuss inequalities. Okay, so we've been talking a lot about how to solve various types of equations, and so the natural next step is to go ahead and take a look at relationships between quantities where we're no longer saying that they're equal like we would in an equation, but instead we're saying that one quantity is greater than the other, or one quantity is less than the other, or etc., right? So we're going to see a lot of linear inequalities in this video, which means that we're going to have to perform some steps to go ahead and get x isolated so that we can go ahead and figure out what our solution set is going to be. One of the special things about solving inequalities, though, is that we are going to have to remember a special rule, and to demonstrate why that rule needs to be considered, I'd like to go ahead and take a look at this example that I've drawn up here at the top. So this is just a simple statement. There's really nothing to solve here. This is just a statement that the number -2 is less than the number +3, okay? And so we can intuit that by looking at the number line, right? So we have the number line is this really visual way of being able to represent, how we might compare numbers in terms of their value, right? So if -2, of course, is right here, and 3, of course, is right here, then one of the ways that we can interpret this less than sign is by saying that on the number line, -2 is to the left of +3, okay? So I'll say that here, to the left. All right. But here's the thing. Whenever you solve an inequality, you're going to have to remember a special rule, because if I were to go ahead and do something to both sides of this inequality that might change the sign of my numbers, like say, for example, if I were to go onto the left-hand side and multiply by -1 and then do the same thing on the right-hand side just to keep things balanced, then take a look at what happens, right? So what you're going to end up getting here is going to be +2 is less than -3. And if you go ahead and interpret that less than sign in the same way as to the left of on the number line, well, +2 is not to the left of -3, okay? So -3 would, of course, sit right here, and +2 would, of course, sit right there, and we could blatantly see here that -3 is to the left of 2. So what that's going to mean is that anytime you guys change the sign of your numbers, or, whatever like that, then you're going to have to change the direction of your inequality to make things make sense in terms of the number line. So it's going to say that down here, right? So when we take a look at linear inequalities, we're going to solve these using the exact same steps as if we were solving a linear equation, except when you multiply or divide both sides by a negative number, because remember, that's going to change the sign of the numbers that we have on both sides. We're just going to need to flip that inequality symbol around, okay? And then it also says here that answers must be in interval notation. We've practiced that extensively this year, so that's going to come into play. And so again, another example of that is right here. Like, you might perform a step in solving your inequality where you might have to go through and divide both sides by -2 to get x isolated. Of course, +4 divided by -2 is going to be -2, but remember that the direction of that inequality symbol is going to need to flip around because of how we interpret things on the number line, okay? And then, of course, translating that over to interval notation, very, very important, right? So just a couple of quick examples here. Again, these get solved exactly like linear equations, okay? So I might go ahead and start this process by subtracting 3 from both sides. That's going to give us 2x minus 7 is greater than +9. I did not change the direction of my inequality, because when I subtract 3x from both sides, that doesn't change the sign of numbers. It's only multiplying by a negative and dividing by a negative that we need to be concerned with here, okay? And so the rest of this, we're just going to go ahead and perform the exact same steps as always until we get down to our final solution here of, it looks like x is greater than 8. Okay, and so that is going to be our answer, but that's written in inequality notation. We need to go ahead and convert that to interval notation. Okay, and we've gotten a lot of practice with this back in the day, but if you forgot, or if you are struggling with your interval notation, I always think that drawing an actual number line always helps, right? Because if you're going to shade all the numbers that are greater than 8, then that means that you're going to start here at 8. You're not going to include 8 itself, but you are going to shade everything that is to the right of 8, because that's everything that's greater than it. So if we were to go ahead and write this in interval notation, that would be the open interval from 8 all the way to +infinity. And don't forget that a parenthesis means that I'm not including that number, and we always put a parenthesis around infinity because we'll never reach it. So there we go. There's our solution for that first one. For the second one here, same deal. We're just going to go ahead and perform our exact same steps here. I always like to try to get my variable terms on the same side before I continue here, so I might just go ahead and subtract x from both sides. You could have also added 3x to both sides. That would have been equivalent. But here we're going to get 1 minus 4x is less than -4. Just continuing with the steps here, subtracting 1, we get -4x is less than -5. And then now we see in this very last step, we are going to have to perform an operation that's going to change the sign of our numbers. We're dividing by a 4, but keep in mind it's a -4. So that's going to change the sign of both numbers on both sides here. So that means the direction of my inequality is going to have to flip around. So x is going to be greater than positive 5/4. Okay, and then of course to write that in your interval notation, that would of course be the open interval from 5/4 all the way to infinity, because there are infinitely many numbers that are greater than it. Okay, in this next example here, we are just going to do the exact same thing. I might go ahead and start off by adding x to both sides, just getting the x's on one side first, and then taking care of my constants here. It looks like I have a less than or equal to, but the same rules apply. Doesn't matter if you have or equal to or if you don't. We still need to go ahead and be aware of whenever we're dividing or multiplying both sides by a negative number. And I don't think in this example that's going to come up here. You will notice that on the right-hand side, I am starting off with a negative number, but when I solve for x here, I am not dividing by a negative number. So that's not my special case. Okay, I only need to be concerned when I divide both sides by a negative number. So we saw that in the last example. So here I see that x is less than or equal to -5/4, and writing that in interval notation, since there are infinitely many numbers that are less than -5/4, we're going to say from negative infinity all the way until we reach -5/4, and I'm going to go ahead and put a square bracket on -5/4 because we are including it because of that or equal to. Okay, so you can see here that for the most part you solve your linear inequalities in the exact same way that you would solve linear equations, except there's just that one special rule that you need to keep in mind, again, because of how we interpret these results on the number line. Another type of inequality that you're going to come up against is what you call a compound linear inequality. So in English class, you might have learned about what a compound sentence is back in elementary or middle school, right? So that's a sentence that is basically made up of two smaller clauses joined together by a conjunction, like and or, okay? And it's the exact same thing here, where we're taking two mathematical statements, two linear inequalities, and we're joining them together with a conjunction, and or, okay? So there's basically two situations that you're going to be up against, and there's either going to be and inequalities or they're going to be or inequalities. And so basically just a little bit of background on what you're going to need to keep in mind whenever you have one of these. But you'll see here that it's going to be a little bit harder to tell them apart when they don't explicitly write that word and or. So what I want you to do is keep in mind that if you see a less than symbol, then that is automatically going to mean that you are an and inequality. And to help you remember that, you can go ahead and remember this little mnemonic device. We can say less than. I know that's a little bit silly, but that does kind of give you a way to help you remember that any less than symbol you see, that is going to have to be an and inequality, right? So if it goes x is less than something, that's an and. To help you remember the or, think greater. If I could spell it right. So great or. Okay, so in this context, if you see a greater than symbol, if x is greater than something, and that's going to be an or inequality. And it'll typically either say the word or it will just go ahead and present it to you in a different way. But if it says x is greater than some number, that's going to be an or inequality here, okay? And so just taking a couple of looks at a couple of examples of what we have here, right? So this right here is going to be one of the ways that these compound inequalities are going to be presented to you. And the idea is that since they are basically getting at the fact that 1 is less than this number, 2x plus 3, and at the same time, this number 2x plus 3 is less than 9. Since this mystery number 2x plus 3 has to fit both of those descriptions at the same time, the first one and the second one, then typically we consider this to be an and inequality, and we would go ahead and write it in this way, okay? Now, you don't have to split it up in the way that I did it here. This was just to kind of demonstrate to you that this was an and inequality. But whenever it's given to you like this, we're going to go ahead and just solve this as if there were 3 columns of my inequality to solve here, right? So what I might do to just kind of start me off here is do a little bit of separators down the inequality, just so I keep in mind what my 3 columns are. And I'm just going to solve this like a regular equation, again, keeping in mind anytime I divide or multiply by a negative number, I'm going to have to change the direction of my inequality. Other than that, the steps here are exactly the same, just that whatever you do to one column, you have to do to the other columns here, okay? And so my less than signs are going to drop. And then I've got 1 minus 3, that's going to be negative 2. That leaves 2x in the middle, and that's going to be 6 on the right, okay? And then continuing to solve for x here, I would simply just go through and divide by 2, in which case my less than signs would drop, negative 1, x, and 3, okay? And so this is going to be your solution set written in inequality notation. Just keep in mind we're going to have to go ahead and write that with our interval notation. So the way that I would do that, of course, would be to say the open interval from negative 1 to positive 3. And again, open interval with those parentheses because I don't see those or equal to's on my inequality. Okay, this is another way that a compound inequality can be represented to you with that actual word conjunction or in between. And so obviously that's going to mean that this is an or inequality. And basically there's no tricks here. We just need to go ahead and solve both of these, goodness, can't even talk. Solve both of these linear inequalities separately and then consider our answer as the whole thing, right? So let's go ahead and just simply add 7 to both sides of this. 3x is greater than 14, and then divide both sides by 3. In which case we'll see here that x is greater than 14 over 3. Or we'll see over here that in order to get x by itself, we see that big divided by 4. So one thing I might do is go ahead and multiply everything by a positive 4. Important that we point out positive there because, again, if it was negative, we'd have to change the direction of our inequality. So it's going to stay the same there. So negative 8 on the right-hand side. And then go ahead and subtract your 3 over, in which case you'll see here that x is less than or equal to negative 11, okay? And so our answer written in inequality notation is right here. X is greater than 14 over 3, or x is less than or equal to negative 11, okay? But the thing is that whenever we are writing our answers, we need to, of course, write them in interval notation. And again, I think it's a little bit easier if you start off with a number line to just kind of visualize your solution set there. So negative 11, of course, would be a way out here. There's 0, and then 14 over 3 approximately would be somewhere right here. Again, I'm not really looking for precision on the number line here. I'm just looking for a visual, right? So because I need to be less than or equal to negative 11, I'm going to go ahead and shade in 11, and then shade everything to the left. Because I have to be strictly greater than 14 over 3, I'm going to put an open dot on 14 over 3 and then shade to the right. And this is one of the reasons why we call this an or inequality, is because if you were to go ahead and build your house, you cannot build it in both of these regions at the same time because they point away from each other. These are disjoint regions. So I could either build my house over here, or I could build my house over there. I cannot build my house in the same two regions at the same time, okay, because these are disjoints. So what I might say here is that from negative infinity all the way until I reach negative 11, that is one of my open intervals, and I'm going to unite that, since they're disjoint, with the open interval from, actually on that negative 11 I should have included a square bracket because of the or equal to. There we go. Make that fix there. Over 14 over 3 all the way to infinity. And there we go. There's our solution set written in our interval notation, okay? And so very important to figure out if you're going to be an and or an or. I will tell you that all of your answers, whenever you have an or inequality, are going to have one of these union symbols in between, okay? If we were to take another look at number 4 again and graph that, then the reason that this would be an and is because if I wanted to go ahead and shade this region, all the numbers that are going to be greater than negative 1, then I could say negative 1 is right here, and then I would be putting an open dot on 1, and then I'd be shading that away to the right of it. If I were to go ahead and shade this other region here, so taking a look at that here real quick, x is less than 3. Since I have to put both of those descriptions at the same time, I might say positive 3 is right there, and then open dot, and then I'd be shading that way. Well, you can see that these two regions would be shading towards each other, and so we just consider that to be one region, and that's why it's an and, because I can go ahead and build my house in both regions at the same time because they point towards each other and create one single region that I can build my house in. So this is going to be an and situation as far as the graph is concerned. So it's important that we are aware of how both of those work there, okay? I'm going to go ahead and skip these next couple of examples just because of time and the sake of the video. But just remember that, again, your special rule, anytime you multiply or divide by a negative number, the direction of that inequality symbol is going to have to switch around. And then I think whenever you're writing the solution set in interval notation, it's a little bit easier to think about if you actually draw yourself a number line. But that's all I have for this video. Thank you very much for your attention. If you guys have any questions whatsoever, then please let me know. But I will speak to you guys in the next one.